Hey everyone, Mr. Ray here with our next grade 10 academic lesson. If you remember most recent lesson, we looked at, most recent two lessons, we learned about these things called trigonometric ratios, where you're looking at a right triangle and you're looking at the ratios of two of the three sides, whether that's opposite, adjacent, hypotenuse. We used a little acronym to help us remember the ratios, SOHCAHTOA. And so, for example, sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tan of an angle is the opposite over adjacent ratio. Okay, and we're able to use these ratios in conjunction with our calculators to figure out unknown sides and angles in the right triangle. It's a very powerful little tool. So what we're going to do today, we're just looking at two word problems that involve right triangles. A little bit different than you might have seen on the previous ones. So maybe we're going to learn a couple of new definitions here, angle of depression and angle of elevation. And usually this is something I like to show you guys in class. It's kind of hard to do with a piece of paper. So before we get into the questions, I just want to talk about this, okay? So say you've got a hill and a valley, and this is you up here, okay, and maybe your friend's down here, and maybe a little seagull is flying up there. Okay, so now if this is you. If you're looking up at this seagull, obviously the seagull's above you, or at least in this case it is. If I asked you, well, what's the angle of the seagull, right? Well, you'd probably say, well, it's got something to do. I could draw basically a line from my eye to a straight line from the eye to the seagull, but how do I measure that angle? Okay, and the clue here is we use the horizon line. Okay, so horizon line is basically like a horizontal, like horizontal from your eye. Like what if you look straight ahead from where you were, you basically have this horizon line. Okay, and it's going to be parallel with the Earth's surface if the Earth was flat here. Okay, it goes on forever. So if I'm looking at the seagull, which is above, that's an elevation, right? Elevation means looking up. Okay, so this angle here, this is called an angle of elevation. So angle of elevation is always when you're looking up, and you measure the angle from the horizon line, the horizontal line. Okay, so that's the angle of elevation. Well, what if you're looking down? Here's your friend down here. Try to draw a relatively straight line. So you're looking down at your friend. Okay, and how would you measure that angle that you're looking down? Well, again, you don't have anything physical to measure it from, like you would, from the ground, or because the ground's not really flat here. But same idea applies here for angle of elevation. This is called the angle of depression. So depression means down. So the angle going down, if you want to measure that, so obviously it's measuring to this line here, but it's also measuring from this horizon line as well. So in this case, this angle here would be the angle of depression. Okay, so it's a lot easier to have a picture like this and understand it than just two sentences in a definition. Okay, I think the book would have something on that as well, but the important part here is you basically have a horizontal line that you're measuring these angles from. And the horizontal line is horizontal to the Earth, not specifically this hilly Earth, but where would the flat Earth be? Okay, so we raise it up there. Okay, so that's what these two things mean: angle of depression, angle of elevation. It's important to know where that angle actually is. Okay, so got a little concept there as well. Now, what we're going to do is, in the first example, it's a two-dimensional problem. We're kind of looking at something from the side. And the second example is actually a 3D problem. And in both cases, we have two triangles. So we're going to see how we can combine two triangles and answer different styles of questions. Okay. So this is our Romeo and Juliet question here. Except they're not Romeo and Juliet, they're Kim and Yuri. And it's a modern day problem. They live in apartment buildings across from each other. The apartment buildings are 30 meters apart. Here's Kim's balcony with a K, and Yuri is in the slightly higher floor, I guess. There's his balcony. Now, if we're, just read this, because the diagram basically shows you everything that's written here. So the angle of depression from Kim's balcony to where Yuri's building meets the ground. So here's Yuri's building, here's where it meets the ground, right? So if Kim is looking down at that corner, right? Well, there's the line that, where she's looking. And how do you measure that? Well, that dotted line there, this is the horizon line, right? So that angle of depression is 40 degrees from there, that horizontal line, to that line down, going down there. Okay, and then if Kim looks up to Yuri's balcony, well, again, you have the same thing as with the seagull I just talked about. You start from the horizon line and you go up to that vision line to Yuri's balcony. So in this case, that's the 20 degrees inside here. Okay, so and when you look at this, well, it sort of looks like one triangle, but we're actually going to break it down into these two separate right angle triangles. Okay. Let's keep reading. I guess we don't even know what it's asking yet. The angle of elevation from Kim's balcony to Yuri's is 20. We just did that. How high is Kim's balcony above the ground? So basically we want to know that height. And how high is Yuri's balcony above the ground? So we want to know that height. Okay. So now in terms of these two triangles, you can kind of see, looking at these two triangles here, that line here from this bottom triangle, that's the same as this. So that side there would be the height of Kim's balcony. And if we combine both of these sides here of these two triangles, added them together, we get the height of Yuri's balcony. So basically we're going to try to solve this side and solve this side. And that's going to give us eventually both the answers we want. Okay. Now they did give us a triangle. A lot of times it'll just be words, and you have to kind of interpret this and create this. So this is a little bit of an advantage when they give you the triangles ahead of time. So I'm just going to kind of take away some of the stuff. I'm going to recreate these two triangles. Not very well drawn, but I'm going to put some labels on them. Kim, K for Kim, Y for Yuri. I'll put A and B here because I need two other letters. Okay, these two angles are 90. This angle is 20. That's the angle of elevation. Angle of depression was 40. What else do I know? So remember the 30 meters of distance between the two buildings? Well, that applies anywhere along here, right? So that line, that horizon line that we drew there, that's 30 meters as well. Okay, and that's actually the only distance we know. We know the two angles and we know the distance. We don't know the one. And you notice this is a kind of a common side for both triangles. So that's going to be doubly useful because we can use that in the upper triangle and the lower triangle. So first thing we're going to do is I'm going to look at this bottom triangle, And when you're dealing with multiple triangles, obviously you want to label the triangles so you can talk about them, identify them. But in this case, when I have two, and I'm going to do something in step one, I want to talk about what triangle I'm using. So using triangle KAB, and that's important because I just don't want to start throwing angles and sides and you know, your friend or your teacher has no idea what you're talking about. So communication, very important. So using that triangle, so the lower triangle, now there's my right triangle, there's the angle I know, okay? So if I'm labeling these sides, well, that's the opposite side, that's the hypotenuse, and that's the adjacent. So in terms of what sides am I going to use, do I want to know this or do I know that side? No, I want to know this side, and so that's the opposite side, and this side is the adjacent side. So I want the ratio that uses opposite and adjacent, and if you remember SOHCAHTOA, that says it's going to be tan. Okay, so remember you have to put the angle here. You just don't put tan equals. It's like putting tan equals is like putting empty square root equals. It makes no sense. Okay, it has to have an argument that goes with the function. Okay, so in this case, tan of the angle 40 is equal to the opposite side. Now the opposite side, instead of calling opposite, I'm just going to give it, you know, variable x. That's equal to x over the adjacent side is 30. Okay, and if I want to get x by itself, I multiply both sides by 30. So I can turn this into x equals, and then times this by 30, 30, tan, 40. And remember, when we multiply a trig ratio by a number, we always put the number in the front. Okay, and if we do tan 40 and then multiply that by 30, and we're going to round to the nearest meter, I'm going to actually go to the 10th of a meter for now, because just to give you a sneak peek at what we're going to do next, we're actually going to find that side there, and then we're going to add them together. Well, if I might add them together and then round. Okay, so I'll give my final answer to the nearest meter, but in terms of adding these two together, it's better that I don't round yet, or at least round further down. Okay, so I know that x is 25.2. Now I'm going to call this side, well, I'm not going to call it y because y is already there. Let's call it w. W is this side here, x is this side here. So now we're going to use the other triangle at the top. So using triangle KAY. Okay, so if I'm looking up there, there's my angle that I'm using. That's the opposite side, and I want to know the opposite side, and that's the adjacent side. So opposite adjacent. So again, I'm going to use tan. Okay, but this time it's not tan 40, it's tan 20 because I'm using the upper triangle. Again, so that's going to be opposite, which is W, over adjacent, which is the same side, it's just shared with both. So if I want to get W by itself, multiply both sides by 30. So 30 tan 20. If I do that on the calculator, I get 10.9 meters. Now, I can just use this result. So therefore, Kim's balcony is, now this time I'm going to round it, 25 meters above ground. And Yuri's balcony, move this up a little bit. Now this time I'm going to add these two together because remember Yuri's balcony is that side plus that side, so W plus X. So that's going to be 35, and then plus 1.1, 36.1. If I round that, that's 36 meters above ground. And just to show where that came from, I could put 25.2 plus 10.9. Don't have to, but I'm just for your sake, you might say, well, where did that come from? It came from adding these two together because that balcony needs to know that side plus that side. Okay, so that's a good word problem involving two triangles that they actually share the same side, but we have to combine sides to get one of our answers, to answer one of the questions. Okay, so that's our 2D word problem. Here is a 3D word problem, and I took this straight from the book, textbook, so if you want to refer to that. So let me explain. Hopefully you can see this okay. We've got a river that's kind of flowing through here. We've got it's kind of a flat grassy area on one side, and then the other side we have this vertical cliff, and then on the top we have like a plateau, like a plane up here. So we've drawn in some triangles. So this triangle here, this is the vertical triangle. It goes straight up in the air. So it kind of goes along the river from this point X, which is on our side of the river, to C, which is directly across at the base of the cliff, and then F is at the straight above C, where the plane is. Okay, so you got that triangle there. It's a vertical, like it's standing straight up, and you've got a right angle there because, well, this cliff happens to be a right angle to the river. Okay, so there's your first triangle. Then you've got this other triangle here. So this, you can see this is another right triangle. Now because it's 3D, you can see that it doesn't look like a square there anymore. It's kind of an angled square just because I'm trying to represent it in 3D. So there's our right angled triangle there. And from this side, like we identified that point C is very important because it's on both triangles. We just pick a point that's still on our shore that makes a 90-degree angle here, measure that distance, we measure that angle, 52 degrees, which we can do without getting wet. We can just measure that. We can also measure the 61-degree angle without getting wet or having to climb a cliff. So we've got our two right angles, and we've got two other angles and only one measurement. And our goal here is to find the height of the cliff. Okay, and this is what I talked about earlier. It's kind of cool that you can use this math tool to calculate distances like the height of a tree and distance to the moon by using triangles. Okay, GPS is based on that. It's a little more high-tech than what we're doing, but it's the same principles. Okay, so here's a word that you'll probably never use again. A theodolite is an instrument used by surveyors to measure horizontal and vertical angles. So that's the tool that they use to measure the 61 and the 52 angles. Measurements are taken in order to find the height of a cliff on the other side of a river. As shown, find the height of the cliff to the nearest meter. Okay. So, again, this is a triangle that's involving, it's a word problem involving two triangles. And just like the other triangle, you have a side that they share. Okay, but this time it's in 3D. So, like I said, that first triangle is vertical. The other triangle here is horizontal. It's like lying, if it was a real triangle, it'd be lying on top of the river, flat. Okay, so when you're doing something like this, okay, I'm going to put, what we want to find is this side here, H. Okay, now this is what I would consider working backwards. Okay, so if I'm trying to say, okay, I want to get H from this triangle here, well, I know the angle of one side. I know the angle between these two sides. I know that's 90. I could actually figure out what F is. So I could actually get all three angles. But unless I know one side minimum, there's no way I could get another side. Okay, so right from the get-go, I can't. I'm trying to get h. I don't have enough information. I need to know one more side. So this is where, after you've done these a little bit, you'll say, oh, how could I get one more side? Well, probably this side here I could get because I've got another triangle that has that side. So let's now focus in on that side, on this side here, XC. Okay. So rather than get too involved in that, let's show what we're going to do here. I want to find the length of XC using, now that side is actually on both triangles, so I have to be specific, using triangle, the triangle on the bottom, CXY, or whatever order you want to call it. And it's always good to do it, breaking it like this into steps, because now I can actually draw the triangle, and I can draw it in 2D. Okay, so there's my right angle, so that's where my X is. I know that I could put my Y here, and I know from X to Y that's 75 meters. And I know that this angle is 52 degrees. And what else do I know? Well, that's a C up here. That's it. So what do I want here? I want to know what XC is. I want to know this side here. That's my goal for this step, okay? So now you got to figure out what ratio you're going to use, because there's the angle I know, 52. Remember, you can't use the 90 as the angle. It has to be one of the other two. So there's my angle. So I know this side is 75 meters. So that's the adjacent side. What side do I want to know? The opposite side. So tan again. Seems like we're got a string of tan questions. So tan of the angle 52 is equal to opposite. Remember, tan is TOA. Opposite over adjacent. So that's going to be XC over 75. If I get XC by itself, multiply both sides by tan by 75. So XC is equal to 96 meters. Now I could go to one more decimal place, but in this case I'll just leave it like that. So I know that side is, that common side there is 96. So if the question had been how wide is the river at that point, we know the answer is 96. But that's not what they asked. They asked what's the height of the cliff. So our part B is going to be now looking at this vertical triangle. Okay, so we got F up here. There's the side that I've called H. There's my XC. And I know I just figured out XC from the previous question. That's 96 meters. And this angle at X is 61 degrees. Okay, so you can see the benefit of drawing the triangle that you're working on, because when you're trying to figure it out here, you could do it that way, but I see lots of mistakes made. If you can draw it big and labeled very obviously, you do a better job at actually solving what you're trying to get. So in this triangle here, we're going to try, this time we're going to find H using triangle XCF, which we kind of already knew because I drew the triangle first. Okay, so what am I going to do here? So there's my angle of interest, 61. I definitely want to have this side in my ratio, so that's going to be opposite. And then the other side that I know is going to be adjacent. So again, I'm using tan. So tan of tan 61 degrees is equal to opposite, H, over adjacent, and multiply both sides by 96. H is equal to 96 times tan 61. And on the calculator, that works out to 173 meters. So therefore, the cliff is 173 meters high. Okay, so again, a pretty cool question. Just like the balconies, you know, you can actually physically measure, but through using trigonometry and measuring angles and sides from the ground safely, you can actually figure out using some good mathematical skills and trigonometry tools. Okay, there's a few questions at the bottom here. These are all word problems, so you know, I would just ask you to kind of look through them, pick a few to try before you look at what I did, because you know, if you look at the solutions before you actually try it, it seems too obvious. Oh yeah, I would have done it that way too. But if you don't see my solution and you tried it by yourself, it's a little more difficult. So it's important to go through the learning process of trying it yourself first, rather than just looking at my answers and going, oh yeah, that makes sense. Okay. Now for what I've decided, there's 2 more lessons left in trigonometry. This will be the last lesson of this week. There'll be an assignment on Friday, basically on trig ratios. So lessons 1, 2, the last 3 lessons, the one from last week as well. And then next week we'll just do 2 lessons and have another assignment just on those 2 things. And then we're done trigonometry. And the following week we'll start linear systems. So that's probably 2 weeks, I think. So we're getting close to the end. So hopefully you can stay motivated. I should be getting some marks to you soon. So thank you for being patient. It's more important to me. It should be more important to you that you feel like you're learning something and you're going to be ready for grade 11, especially if you're taking the university course. It's going to be a challenge even if you're not taking it like we are now. So just do your best, try to learn. Don't worry so much about the marks, okay? Because, you know, nobody cares about your grade 10 math mark when you're going to university or college. I know you guys want to do well, and you will do well if you're working hard, okay? So don't worry about your marks. I will get those to you as soon as I can, and I think most people will be happy. Okay, all right, guys, have a great day, and don't forget about the math help Thursday this week, and next week Tuesday and Thursday as well. Okay, have a great day.